Okay. Good evening, my senior 5 chemistry students. During the term, we discussed some topics of physical chemistry up to correlative properties, and I'm very sure we completed them very well. I sent you some numbers to try about correlative properties and some other topics. I don't know whether you are doing something sensible, but if you are still playing, then it is very bad. So today we want to start off with thermochemistry, and this one is going to be handled throughout using our YouTube platforms. So, like for today, lesson 1, according to what I have sent on your WhatsApp, we are going to split this topic in about 7 lessons, and this is the first lesson where we're going to look at what does thermochemistry mean, the factors, the enthalpy, exothermic and endothermic reactions, standard enthalpy of change, the laws, then formation and combustion. So these ones are making our lesson 1. So when we say thermochemistry, then we want to establish that thing of saying that is there heat involved? If yes or no, the opposite will be absorbed. So for all reactions in chemistry, a reaction can involve by liberating heat or can involve by absorbing heat. So using this knowledge of thermochemistry, we shall be able to define and we shall be able to establish the reactions that will go via involving heat or liberating, or those ones that go with absorption of heat. So according to the notes we have in our WhatsApp, we said that thermochemistry is the study of heat changes which accompany chemical reactions. So accompany chemical reaction is heat liberated or heat absorbed. That is what we are going to be dealing with if it comes to thermochemistry. So all chemical reactions are accompanied by either absorption of heat or loss of heat. So we are saying that all reactions, there is liberation or absorption. Those are the only two cases we can get. But when we look here, we have factors. What brings about the heat that will either be absorbed or liberated. So when we talk about the factors, the first thing we shall be talking about will be the mass of the substance involved in the reaction. The mass of the substance that will be involved in the reaction. And this one here can be done like this. For example, we want to establish that if someone burns 10 grams of carbon and another one burns 1 gram of carbon, then will they get the same heat? That's what we want to tell when we say mass of the substance involved. We can give a clear example like saying one person getting a strip of firewood and places this strip in one fireplace, and then another one gets 2 pieces of firewood. These 2 people cannot get the same heat. Obviously, this one will have a lot of heat, but this one will get very less. So implying that the much amount you will be using for the reaction will lead to more energy, either liberated or absorbed. Then the next factor will be the temperature. The temperature. The temperature at which the reaction is taking place. So, the higher the temperature, then the more heat will be observed. And the lower the temperatures used, then the lower heat will be observed. And then another thing, it will be the states of the reactants. For example, you are reacting a gas plus a gas. This reaction will be different from a reaction of a solid plus a solid. So implying that if we want to determine the amount of heat, energy involved or absorbed during a reaction, you should put these ones into consideration. The mass of what you are going to start with, then the temperature at which the reaction is likely to take place, and then the physical states of your reactants and products. So when you follow the same idea, when you follow the same notes you have on your WhatsApp, then we shall look at saying, like here we have said the states. But then these states must be standard. And when you talk about this one as standard states, then you should be in position to know that our matter is consist of solid, gases, and then liquids. So still these will be our states. But when we say standard state, we are meaning the state of that substance at a temperature of 298 kelvins and a pressure of 1 atmosphere. So another person can say a standard state is that state in which the substance is more stable. For example, when you talk about water, water can exist as a liquid, can exist as a gas, and can exist as a solid. But when you look at water, its most suitable state becomes the liquid, implying that liquid is the standard state for water. We know very well that this one gas is just in steam form and this is in ice form, but it is very easy to convert this solid back to the liquid and then steam back to liquids. So still when we say standard pressure is the 1 atmosphere. So the next thing on our agenda is enthalpy. According to the notes, we said that this refers to the heat energy content of a given substance. So when someone says enthalpy, is meaning the heat energy content of a given substance. For example, we can say that if you get carbon plus oxygen, this one can take us to carbon dioxide gas. Then we put here something like the H of C, like saying negative say 56 kilojoules per mole. So this 56 kilojoules per mole becomes the enthalpy. And of course, at lower levels, we can say enthalpy is heat. So when you say enthalpy and another one says heat, the two people are meaning the same thing. So this enthalpy will take us to what we call enthalpy change. And this enthalpy change, another person can call it heat change. Just because we have said enthalpy is heat. So we said that enthalpy change is given as the difference of enthalpies of products and reactants. So implying that if this is enthalpy abbreviated with H, and you want to know the enthalpy change, dH, enthalpy change, this one equals to the enthalpy or heat content of products minus heat content of reactants. So what you get becomes the enthalpy change. So let us look at another thing on our agenda, the exothermic and the endothermic. So when we say exothermic or endothermic, then this expression will be very, very important. So like here we say that enthalpy change equals the enthalpies of products minus enthalpies of reactants. Then the thing is, here we shall expect two answers. One, we can get a positive answer, and two, we can get a negative answer. But we cannot get both answers for the same reaction. So implying that one reaction can go by positive, another one can go by negative. So this one means what? This one therefore implies that we now be able to tell about exo and then endo. So when we say exothermic reactions, then they will be negative, and then endothermic will be positive. So here, like when we say exothermic, endothermic, positive, negative. So when we say about like exothermic reactions, according to the notes we have, we said that these are reactions that proceed with evolution of heat to the surroundings. So here the heat is liberated to the surroundings. Then implying that what? Implying that the enthalpies here, these ones are lower, then these ones are higher. So this one still, our notes continues to say that therefore on the higher energy levels we have like to the surroundings, and the reactants are therefore on the higher energy level than products. Then we said the reaction have a negative value for enthalpy changes. So we can illustrate this one, and in your notes we don't have diagrams, so please take note. So this is PE and this is the reaction path. So we have something like this. Remember, according to the definition, we have said that the reactants are on a higher energy level. So here we have reactants, then here we have products. Then this one is the PE. So this is the enthalpy of products. This is the enthalpy of reactants. But we say the difference between enthalpies of reactants and products is what we call the enthalpy change. So implying that this one here is what we call enthalpy change. So this top here is what we call activated complex. Then this one here is what we can call activation energy. So this one is what we call energy level diagram. So why are they called energy levels? They are showing us the levels at which we have reactants and products. So for exothermic reactions, reactants up, then products down. So for you, you should be in position to define PE, to define activated complex, to define activation energy. So here, this one here is what?